In this video, we're going to be going through how we can download historic candlestick price data for different cryptocurrencies using Python with Polygon.io. Polygon's a really great data provider. I use it all the time with my clients, and it provides both real-time and historical data for stocks, options, currencies, and crypto. It has some free options, which I'm going to be showing you today, and you'll also be able to use the skills that we'll develop today to use their premium endpoints with more data. You'll also be well equipped to try out their stocks, options, or currencies endpoints, but I'm just going to focus on crypto for this video to keep it nice and short. Polygon's one of my favorite data providers because the pricing is super simple. Either you can use it for free and have access to limited historical data. So if we go to crypto here, scroll down to the bottom, you can see for free, we can get 2 years of historical data and 5 API calls per minute, which is enough for us if you don't need mountains and mountains of data. And even if you do, I'll show you how you can automate downloading of larger chunks of historical data. The first thing that you'll want to do is just sign yourself up for a free account. Go into the dashboards here and look at your API key. This will be different for everyone. You shouldn't show this to anyone. It's like a password for your account. Obviously, I will delete this API key after the video goes up. And we'll be needing this in a second here once we've built out some of our script. The endpoint that I'll be looking at in this video is the aggregate bars one here. So there's an analogous endpoint in every single asset class here. As you can see, there's one for stocks, there's one for options, and there's also one for Forex. I'm just using the crypto one here somewhat arbitrarily. And inside this endpoint here, we can get candlestick data of a specific time format. So we could ask for 1 minute data, 2 minute data, 1 hour data, 5-day data, etc., etc. And the way you do that is by providing different parameters. So you can see the ticker here is X BTC USD. This X here is just the format for cryptocurrencies. Don't stress about it too much. The multiplier is the number of the time frame. So if we wanted 5 minute data, we'd have a 5 there. If we wanted 7 minute data, we'd have a 7 there, so on and so forth. The time span, well, do you want minute, hour, day, week, quarter, year, etc., etc.? Fairly straightforward. There's a from and a to here. So you can either provide a date in this format, or you can provide a millisecond timestamp, which is more precise, and that's what we're going to do. And then there's some simple stuff like, do you want things in ascending or descending order, etc., etc. And so how do we actually send that message to the Polygon servers? You do it by using a REST API web request. Now, what that means is we basically type in a fancy URL, and in return, we get our data. Now, if you just log into your account and mess about with some of these values, so I'll change this to maybe 23 here. Let's get some Bitcoin data, some 5 minute data, let's say. And we'll sort descending. Limits, let's just leave a limit of maybe 10 bars just so that it doesn't fill up the whole screen. I'll copy this URL and paste it into a new tab here. Now it's only giving me 1 bar there, and I'll explain why that happened actually in a minute. But let me just bump up the limit there and it'll now work. So you can see we've got lots of essentially dictionary objects. So if you were to load this into Python, this is what dictionaries look like. We've got essentially a nested dictionary here. And each one of these dictionaries represents a 5 minute candlestick, where we have the volume weighted average, the open, the close, the high, the low, the timestamp, which is just how computers measure time. It's the amount of milliseconds since midnight on the 1st of January 1970, just how computers like to count. And then N here is the number of trades that have gone on during that time period that have been aggregated into this bar. So I hope that makes a little bit of sense. You might want to just try out this yourself, a few web requests, so you get the idea. And then we'll be using Python to actually programmatically process this data. And so we can save it down to a CSV or into our database or however we're going to collect this data. So let's head on over to the terminal here. I already have a virtual environment set up, but you'll want to install packages like requests and also pandas. I believe those are the only two packages that I'll be using that aren't provided with Python. Once you've done that, go ahead and open up a Python file here. I'll call mine example.py. We'll go ahead and import requests, and we'll also import pandas as PD. And while we're here, we might as well import some other libraries that I'll be using a little bit later on. So from date time, import date, date time, and time delta. If you haven't seen those before, don't worry, I'll be explaining them as we go. And I'll also import time here because that's going to be quite useful for us so that we don't make too many requests. As I said before, we're on the free plan here, and so we're limited to 5 requests a minute, so we want to make sure we're not going over that. The way that I'm going to implement this for now is to create a function here called pull one-min data, and that's going to take in a symbol and a date, and it's going to pull 1 minute data for that symbol on that date. So if I give it Bitcoin USD and the 1st of January 2021, it's going to pull all the minutely data for that symbol on that date. So you can follow along with me now, and then towards the end, I'll provide some ideas about how you can adapt things to work for different time frames or to gather data a bit more quickly. So we've got our function here. Now we want to start passing in all the different parameters that we're going to have to provide in our request. The first one of those is going to be the API key. So we'll just make a variable here and we'll call it Polygon API key. Now you'll need to go grab that from your account again. So it's over here, copy the API key, and we'll just insert it as a string here. Do be careful if you push this code to GitHub or anything. It's not best practice to include your API keys inside code, so just be careful with something like that. You can use Python decouple, which is a library I use in my other videos to hide sensitive data. We'll also want the URL that we need to send our request to. So I'm going to set that as Polygon REST base URL. And the way we get that is we go back to the documentation here. If you go up to the very top, you see it's https api.polygon.io. So that's what we need to connect to here. I'll grab this, so the v2 as well. And we'll leave that as a string. So perfect, we've got some of our parameters here. So for me, I want to provide the symbol in the format of BTC USD or Uni USD or ETH USD. As we saw before, Polygon only accepts it if it's got the X and the colon at the beginning. So I'm just going to make a quick adjustment here and say symbol is equal to X colon plus symbol. So we just need to make sure the symbol's formatted in the right way. If we go back to the documentation here, let's look at some other things that we need to start writing out. So we've got the ticker. We also need the multiplier and the time span. So for me, I'm going to say the multiplier is equal to 1 and the time span is equal to minute. Now I'm hard coding these in here. There's no rule against just making these parameters in your function. So you could have multiplier and time span in here and pass them through that way, which would make the script a little bit more robust, but also a little bit more complicated because you have to handle those things later on. So I'm not going to do that in this video. We also have to set the limit here. So limit. Now there's no downside to having the limit be too big as far as I can tell, unless you're only after a certain number of bars. So for me, I'm just going to set this to 40,000. I believe the maximum is 50,000. And this will just make sure that we get all of our data that we ask for. You can also provide the direction that you want your data to be sorted. Do you want in ascending order or descending order? So descending order is going to have the most recent times first, and ascending order is going to have the most recent times at the bottom. It's up to you. I'm going to sort it in ascending order, so ascending. So you want the newest data at the bottom. It doesn't really matter because we're going to sort it afterwards anyway, but just personal preference. Now we need to concern ourselves with the start and the end time. So again, if we go back to the documentation here, you can see there's a from and a to. So you can either provide it in this format, so year, month, day, or you can give a timestamp. You need to know where exactly you want this data throughout the whole of history. With the free plan here on Polygon, we have 2 years worth of historical data that we can pull from. So you can pick any date within that region. How I'm going to implement this here in our function is I'm going to take this date here. So the date I'm going to provide in a year, month, day format. So it's going to be a generic Python date. So date is a Python date format. That's why I imported it up here. And then symbol is of the form XXXUSD. Just so we're a bit more clear about our parameters there, but I'll show you in a second anyway. So we need a start and an end time basically. So for our start time here, I'm going to do a little bit of a trick. So I'm going to do start time is equal to date time dot combine date and date time dot min dot time. Now that might seem a little bit confusing, so I'll run this here and show you exactly what's actually happening, and then it should be straightforward enough. So this function, all it does right now is it takes in a symbol and a date and prints out this start time. So let's do that. Let's call this function down here with a given date. So let's create a date, we'll call it day, and that's going to be equal to date, year is equal to 2021, month is equal to 1, and day is equal to 1. So this is the 1st of January 2021. So I'll print day out here. So day and then day. I'll also call our function here. So pull 1min data. Let's provide it with BTC USD and the date object that we created called day. If we run this, you'll see what's happening. So this is our day object we created here. It's just got a year, a month, and a day. It doesn't have any concept of seconds, minutes, or hours. And what I've done is I converted that into a Python date time object, which is centered at midnight on that day. The reason why I did this is so I can get the exact time at midnight on this day. And I'm going to get that as a millisecond timestamp so that I can send that through to Polygon. Hopefully that makes sense. So this is a date format and this is a date time format centered at midnight on this day. It's just a nice little trick you can use, and then that makes it super simple to extract the timestamp from here. So if I print out start time dot timestamp, you'll see what I mean. So this prints out the timestamp here as a float value. So I believe this is in seconds here, but easy enough to convert from seconds to milliseconds by timesing by 1,000, and then we convert to an integer to make sure it's an integer value. So that's how we're going to get the start and end values here. So start time is equal to our fancy trick. End time, well, in our case, we just need it to be 24 hours after the start time. So I'm going to do start time plus time delta days equals 1. And what that'll do is that'll just create a date time object for the next day's midnight. So we're getting data from midnight to midnight. I believe all the timestamps on Polygon are UTC for crypto, although you may want to check me on that. And so now we've got our start and end times. Let's convert them to milliseconds so that they're ready to be sent off to Polygon in the format they like. So pretty easy. Just start time is equal to int start time times 1000. And then we need a dot timestamp in there as well. Let's put that in here. This is for end time. And then end time over here as well. Okay, so we've got our start and our end times as millisecond timestamps. We're pretty much ready to go here in terms of requesting our data. So we're requesting 1 minute data from midnight on this day to midnight on that day. Let's go ahead and build out the request here. So one way to do this is we can just copy that URL that Polygon helpfully generated for us before, and then we can replace all of the values in this URL with the ones that we've laid out over here. So I'm just going to copy and paste that into a string. I'm going to split it up into a couple of different pieces just so it doesn't go off one screen here. So I'll do a plus sign and I'll do a line break and we'll continue on like that. And I'll do the same thing down here somewhere. So maybe over here. We'll end this string, put a plus sign, a line break, and there we go. So all I've done is I've just split this string over 3 different lines and hopefully it still works. So I'm going to make this an F string, and that means that we can substitute our values that we've got here, so our variables that we've defined, into this string. So the first one that we might want to substitute here is our REST API URL here. So our Polygon REST base URL. So that's going to replace the whole of this section. It's just quite helpful to have it in a parameter up here in case it needs to be changed. We don't have to change it in lots of different places in the script. So it's Polygon REST base URL. And all you have to do is put that parameter in curly brackets here, and then Python will automatically read that into the string because it's an F string. Moving forward here, we need to replace this with a symbol that we had defined earlier. This is the multiplier here, so multiplier. We also need to replace the time span. Then this is the from time, so this is going to be, in our case, our start time. This is the to time, so end time in our case. Sort, well, that's going to be our sort value here. And then we're very nearly done. We just need to change limit. That's going to be equal to our limit value. And then we also have our API key here. So that needs to be changed to Polygon API key. So I hope that's reasonably straightforward there. What I've done, I'm just substituting these variables that we've defined for how we're going to request the data into this F string. And so this will dynamically create the URL that's going to give us the values that we want. And so that's pretty much the hard part, to be honest. The next section, all we really have to do to get this data is to do requests.get request URL and then convert that into JSON format. So we'll save that to a variable, we'll call it data. And let's just go ahead and print out data and see if we've made any mistakes. So we're already requesting BTC USD data for this particular day. And let's see what happens. So as you can see, Polygon's given us a nice error here saying unknown API key. So let's make sure that something hasn't gone wrong here. So after a little bit of fun there, I believe that error was caused by a trailing slash there on the end. And there we go. That seems to have actually worked there. So this is all our data. Again, it's in that dictionary format, like I mentioned when we did our first web request. And we've got 1441 different bars. The reason for that is the way Polygon figures out whether it's going to return the bar is it just looks whether it's less than 2 or equal to the number that we sent it. So if I go epoch converter here, This is a nice website that you can use when dealing with epoch times. You can see that the last candle that we receive here, so remember, I set everything to be in ascending order. So the last candle that we receive is Saturday, January 2nd, 2021 at midnight. Now, really, the way I wanted this to be implemented, I only wanted to get the data from the 1st of January, not including this candle at midnight, which goes from midnight to 1 minute past midnight. Easy way to fix that is just to take 1 millisecond off the end time here, so -1. And if I do another request, you'll see we now only get 1440. And if I were to check the timestamp here on this last one, it would be 11:59 on the 1st of January. But I closed the tab now, so I won't do that again. So I hope this is making sense. We've now created the URL that we use to send the data, and we've actually got the data. Now, all we need to do is clean this up a little bit, and we're pretty much ready to go. So I'm going to clear my terminal here, just so things are a bit more clear when I print things out. If I go to the very top here, you'll see this is actually a nested dictionary. So we've got this information here, so the ticker, the query count, result count, and then we've got results. And results is a list of bars, basically, and each bar is represented by a dictionary, as we discussed before. So we don't really care too much about this metadata, we just want the results here. So let's go ahead and grab those. So if results is in data, well, we want to return data results. The reason why I'm doing this check here is just in case we get some kind of error, we might want to raise an exception. So, else raise exception, something went wrong. And this way the program fails fast so that you're not doing your back test and then realizing after you've run it live that you're missing data. So that's our little function here that grabs all the 1 minute candlestick bars for a specific symbol on a specific day. Let's go ahead and loop through this so that it can manage multiple days of data, as I'm sure most of you want more than 1 day's worth of data. So if we come over here, all we really have to do is we'll create a list here called bars. We'll put this in a loop. So we'll say, how many days do we want? So days of data. I'm just going to set it to 2 for now. And then for I in range, days of data. What do we want to do? Well, we want to do bars plus equals whatever our pull 1 minute data returns. So in this case, this is the 1st of January 2021. And then let's pull the previous day's data here. So to do that, all we have to do is do day minus equals time delta days equals 1. So that will take 1 day off this particular day variable we set here. And then on the next run of this loop here, it'll run our function for that day and we'll get that day's worth of data, which will be added into our bars list here. I'm also going to add a time.sleep here. Now, this is to make sure that you don't go over the request limit. So the limit is 5 per minute. So I'm going to add a 15-second sleep here just to make sure we don't run over that limit. And then once we're all done, all we have to do is convert that to a data frame here. So df is equal to bd.data frame bars. And then I'll print the data frame. And I'll get rid of these print statements here just so they don't get in the way. Okay, so this should work if I let it run. And I get my syntax correct. So there we are. We have a data frame here with the volume. So this is the volume in whatever asset you've chosen. So this is BTC volume. The volume weighted average, the open, the close, the high, the low, the timestamp, and the number of trades that were aggregated. I'm going to show you how to just briefly clean up this data a little bit, and then we'll look at how we can expand our function to include different timeframes. So in terms of cleaning up this data, fairly straightforward. So I'm going to add a date column here. And that's going to be pd.to_date time. And I'm going to grab that T column that we saw before. So if I go out here, you can see the time was represented as a timestamp in milliseconds. So if I go back and I change this here, we'll have to set the unit. So the unit is milliseconds. It's not in seconds or nanoseconds. It's milliseconds. That will create a date column, which will give a human readable date that we can actually look at as humans. I'm also going to trim some of the columns off, so I don't really care about the N column or the T column, to be fair. So I'm going to say df is equal to df, date, O, H, C, and L. I also find the order of their open, high, low, close disturbing, so I'm going to rearrange them here. And I'm also going to have the volume. If you put that in double square brackets there, that will only select those columns for us, which is great. I'm also just going to quickly change the names of those columns. So you can do that by editing the columns attribute here. And I'll set that equal to time, open, high, low, and close. With volume as well, I keep forgetting. And that'll be good. So if I run this again, we should get our nice clean data. So there we go. You can see we've got data both from the 31st here of December and from the 1st of January. The order's a little bit mixed up, so I'm going to add a sort on here. So df is equal to df.sort_values, and I'm going to sort based on time. So that'll make sure that everything's sorted in ascending order by time, and therefore it's all in the right order. So in terms of adapting this script to your use, here are some things that you might want to think about. So let's say I don't want 1 minute data. I want 5 minute data. Well, easy enough. In the first case, you can just set that to 5 and it'll do its job. The problem is there are obviously 5 times fewer 5-minute candles in a day than there are 1-minute candles. And so if you want the same amount of candles, this script is going to take a very, very, very long time, because it's going to have to run over more days of data, and we can only make 1 request every 15 seconds or so on the free plan. If you're on the paid plan, obviously this doesn't apply to you. You can make as many requests as you want, and they're very quick. But on the free plan, we can kind of adapt to this by changing our start and end times here. So instead of skipping 1 day at a time, we can now skip about 5 days at a time. And obviously you want to change that down here, so that this is also going backwards 5 days at a time. So because we're requesting fewer bars, we can make requests over larger periods of time and still have it served in just 1 request, meaning we have to make fewer requests overall, which significantly speeds up the rate at which we download things. Equally, if you wanted, hourly data, this also applies. You can increase the amount of days that we do in 1 request. So you can do 7 days, 14 days, etc., etc. Experiment with it a little bit and make sure that you're getting the amount of bars that you expect. So over a week, you would expect 168 bars. Make sure that you're actually getting those bars before going ahead and downloading the whole series. Just something to be aware of. So that's how you adapt for different time frames. Basically, you just want to change the amount of days that we step through. You can leave it as it is and just step through 1 day at a time, but that will be very, very, very slow on the free plan anyway. To save this down so that you can use it in your backtests, all you really have to do is do df.to_csv, data.csv, and index is equal to false. Oh, that's personal preference really, but that's what I would do. And then we can run it here. Obviously, you can also stream this data directly into a database like TimescaleDB. I have a nice free course here available on YouTube that you can watch about how to set up your own TimescaleDB if you want access to large amounts of data without handling lots of CSVs. But for now, CSVs work quite well for us. So when this is finished running, should be another few seconds here, I can open up this data.csv file. And you can see we've got our 5-minute candles here for the 2 days that I requested. So I hope that all made sense to you in how we built this script to scrape data. And you can use the skills that you learned in this video to work through all of these other endpoints and see if those serve your needs just as well or even better. So for example, if you wanted to get all of the bars for all of the available cryptocurrencies on a given day, this endpoint would be more useful. But it's exactly the same logic about building a request URL here and then passing that through to request.get and converting to a pandas data frame. It's all the same idea. So I hope you found this video really useful and that it helps you get all the data that you need for your backtests. And so I'll see you in the next video.